Welcome to this third part of the series gaze control keyboard. In the first part, we detected the eye from the original video source. In the second part, we detected the eye blinking, so when we were blinking both eyes, and that's where we're left. And now in the third part, we're going to detect the gaze of the eye. So mostly we're going to focus in three directions. If we are looking at the center, like I'm doing now, if we're looking at the left side, or if we are looking at the right side. Let's see the code. I'm going to remove my image now, and let's run the script from the last video. This is the script that we have. When I close the eye, you can see that really precise the code can detect the blinking. Now to check the gaze of our eye, we cannot use the dlib library anymore, but we have to do that by ourselves. So first we're going to select the eye and take on one screen, put just the eye, and then we will work on that. So first thing, let's select the eye area. From the landmarks here, we'll detect the blinking. So let's put some comment so that everything will be more readable. Detect blinking. And here, gaze detection. Now we need to select the eye. As we know, we have the points from the landmarks. We have the precise point of the eye. Let's now focus only on the left eye. We're going to take let's look on the screen here, landmarks point. We're going to take points 36, 37 to 41, and we're going to draw a polygon first. So let's do it this way. We create, let's call it left eye region is equals to, let's create an array where we put all the points from the left eye, np.array. Let's put inside all the points. So we take landmarks.part 36.x, landmarks.part 36.y, and this is only the first point, so let's put it inside parentheses this way, then comma, and we're going to do that with all the 6 points from our eye. So we have the first, second, third, fourth, fifth, and sixth. Let's put the index of the other points, 37, 38, 39, and also this one, no, what am I doing? 39, 40 and 41, and just remember to define the array type of numpy, and also I forgot all the comma after each one except the except the last one, and then after the array we put comma, and we define np.int integer 32. This is we're going to create an array. We're going to define the type of the array with the numpy. Once we have all the points, let's for example print the point left eye region. I run the script, and you can see here are all the points where the eye is located. So let's now draw a polygon. cv2.polylines, we're going to draw the polygon on the frame. The points is going to be left eye region, is closed through. The color, let's make it red. So 0 blue, 0 green, and 255 of red, and thickness 2. Let's run the script and let's see what we get. Probably this must be inside an array. I'm not sure right now, but there is some error in the function line 59, so that I'm doing some mistake in the draw polylines function. Okay, now we're focusing on the left eye, and here I have a polygon. This polygon defines exactly the inside the eye, exactly the sclera, iris, and pupil, and all the rest is out. Using this polygon, we can take the exact region of the eye so that we can focus only on that part. Let's see what's the best approach. Okay, first thing, let's now put the eye in a new screen. How can we do that? To put the eye in a new screen, we should take the extreme points of this polygon. So the top point, which is this one, the extreme left, the extreme bottom, and the extreme right point from this left eye region. Let's take a look. How can we do that? Let's take a look at the array, and then it will be much more clear for us. We can print left eye region this way. Let's see the result. Let's see, for example, this one. 285 on the x-axis, so all the first values are the x-axis, and all the second values are the y-axis. The extreme left will be okay, I'm going to print it again. The extreme left will be the fact that when I'm printing I cannot show anything, so let's put some really long waiting time so that I can show you while I am explaining everything. Okay, we have these values. The extreme left will be close to this part, so it will be the lowest value of the x-axis. In this case, it's going to be 288. The extreme right is going to be the maximum value in this part. The top is going to be close to 0, the closest to 0, so it's going to be the lowest y value, so in this case 179, and the bottom is going to be the highest value, in this case 188. We have all this in the eye array. So to select the part, the region of the eye, we can take the minimum and the maximum of both x and y. And we have the numpy functions for this. Let's go here. We take first minimum x is equals to np.min, and we take this from the left eye region, and then we need to put an array, and 0 in this case is the we are going to take the first value when we put 0, and the first value are the x's. When we want to detect the maximum x's, it will be really similar, max x and p dot max, and this is the same, and then maximum minimum mean y is equals to np dot mean. Let's take this, and the y, as we said, is the second value, so index 1, and same here, max y and p dot max left eye region 1. With these points we can select the area of our eye and only show the frame of our eye. So I will be equals to frame, and from the frame we take minimum y, min y to max y, and then min x to max x. With this we can show our eye. cv2.i, no, cv2.im show eye, and then eye. Let's run it and let's see if everything is correct as we would like to. I forgot to change the weight key to 1 as it was before, but anyway I see that it's working anyway. We have the second screen, and let's move it, and you can see that here there is my eye. Doesn't matter where I go on the screen, we will have always the eye in this area. For us to check it better, let's increase the size. I is equal to cv2.resize. We want to resize the eye, and let's make it, we don't define any size, specific size, so we say none, but we define like 4 times of the size, or let's make it even 5, fx 5 and fy equals to 5. Also, we don't want to see the lines. We don't need to see the lines, so let's I'm going to comment in where we define blinking ratio. I'm going to comment the line where we design the lines, where we draw the lines. And so let's run the script and let's see what we get. Okay, now it's 5 times the original size, so it's for us easier to see it. There is of course some improvement to make in this part. For example, we can remove this region where it's not exactly our eye. We want only the inside part, and that's going to take some time. Maybe for the moment we can skip this. Let's first convert the eye in grayscale format, and then we'll create a threshold and we'll see if this threshold can be enough precise for us to use as tracking method of the motion. So we go the eye before the resize, gray eye is equals to cv2.cvt color of the eye, and then cv2.color underscore bgr to gray. After this, underscore threshold eye is equals to cv2.threshold of the gray eye. The thresh value, let's say 70, because 70 is the value that I was trying before myself, and it seems to me the one that works the best, in my case at least. And cv2.threshold thresh binary inverse. Let's now use this threshold, show this threshold, c2.im show threshold, and then threshold I, and let's see. Let's see, I have it on the other screen right now. Doesn't say much in this case. Probably it's not thresh binary inverse, but just thresh binary. Anyway, also let's increase the threshold to 5 times like we did for I, so that we can see it better. Threshold I is equal to c2.resize the threshold I and 5 times. Somewhere, okay, this is the threshold. I'm looking now in the right side, and that's what I see. If I look in the opposite direction, it's different. It's enough accurate for us, but still there is this part to be removed. So let's see. Now things are going to get a bit tougher, at least from the coding side. To remove this part, before selecting this region, we need to create a mask where we cover all the image except the eye. Once we have the mask where we cover all the image except the eye, then we can take the region of the eye. Let's do that step by step so it will be easier to grasp. Let's first create the mask outside. No, not even outside. Let's create it here somewhere, the mask. Mask, it must be of the same size of the original frame, so we can say mask is equal to np.zeros, and here we need to define the size, which is, I know that in my case it's 480 by 640, and np.uint8, or even better, to take the size of the original screen. If you don't know it, it would be the height, width, and channels. We know in the channels, so we put underscore is equals to frame.shape, and then we just copy height and width. We show the mask just here, cv2.im show mask, and then mask. And this is the way to create a black screen. There is just everything black. And I'm starting it just to show you how it is. Just a black image of the same size of the frame, nothing more. After this, we are going to draw the polygon in this region, the polygon of the region of our eye. And it is mask. We copy this one, cv2.polylines here, and the color must be white, so it's only one channel image, so we don't need to put the 3 elements, only one. It's white, so 255. And after we have the polygon, we need to fill the polygon, cv2.fill poly on the mask, and the points are the left eye region, and there is something that I am missing probably. Okay, also polylines not on the frame but on the mask. The eye region, okay, the color of the polygon 255, so we're going to fill the polygon of white. And we get an error because we're filling the mask before creating the mask. So let's put these two lines below mask and let's see what we get. Okay, this is exactly the region where we have our eye. So when we have this mask, we can put this mask over the image, the original image, so that we can extract exactly the eye. So it will be in this way. Left eye is equals to cv2.bitwise, and we take the frame again, or even better, we let's work with the gray image. We take, instead of the frame, let's take the gray image. We don't need to take the eye in colors. Left eye will be equals to gray and gray, and then we put the mask. Mask is equal to mask, and let's show, instead of the mask, let's show left eye and left eye. Exactly what we need, and in this area we have only the left eye. So we can clean the code that we did before. We can do this. We can do it this way. Let's remove eye and gray eye, and let's take from threshold eye of, no, let's make one step back. Let's remove gray eye and let's use gray eye here, as we are taking the image already from the gray, and we will take it from gray. Actually, not from, we are going to take it from left eye. I'm sorry, but I'm making a big mess. We're going to take it from left eye here. Left eye and gray eye. It's better if you use maybe different names, because I'm making a bit of confusion with these names right now. And then the threshold of gray eye, and let's show gray eye here, and everything should be fine right now. And let's see now the result. Okay, here we have eye. We can see now that the eye is perfectly in this region without the rest of the face that we didn't need. So even the threshold is more clear. It's all for this video. We're going to see in the next video how to use this threshold to detect precisely the gaze of the direction. Remember to subscribe if you want to be updated to this series and to all the videos that I'm going to release soon. This is all, and now let's stop the video.